Okay, so we are going to continue on with 5.3, the sum and difference formulas, which we started just rewriting some different angles exactly using these. So you're going to want to have your trig property sheet handy, and we're referring to these top two on the back side. And what we're going to do a little bit of today is proving, and some of these are actually other things that are on the trig property sheet. And so if I asked you to prove that the cosine of pi halves minus x was equal to sine of x, using a sum or difference formula, this property we see is a cofunction identity. So it's the one right here. And we know that it's true, we've used it, but how do we get there now that we know the cosine sum or difference formula? And this is where the proof in this section is a lot more straightforward than the proof we've previously been doing, because I'm telling you which formula to use, and it's a matter of doing some substitution and then showing that it's true, and you have to know a little bit of your unit circle. In your trig properties sheet, we have the two angles written as u and v, so I'm going to just write those there a second. And so this is u and v here, and we're going to use this formula, and what we are going to do is plug in pi halves for u and x for v, and then we're going to get some things to cancel out once we put in the trig values from the unit circle. So using this, I'm going to write that this expression equals cosine of pi halves times cosine of x. And since this is a subtraction sign, I am going to use the addition sign. So plus sine of u, so sine of pi halves, times sine of x. Okay. And just remember, our goal is I'm trying to show that this is going to equal sine of x. So the next step is two of these things are values on the unit circle. I know what the cosine of pi halves is, and I know what the sine of pi halves is. It's 90 degrees on the unit circle. The cosine of pi halves is 0. So I need you to show that you know that it's 0. So we have 0 times cosine of x, which in a second is going to cancel them. The sine of pi halves is 1. So we have 1 times sine of x. Then I have 0 times cosine of x, which cancels, and I'm left with sine of x times 1, which is 1 times sine of x. That was what we were trying to prove, so this would be the end of this proof. So then we can use this to prove other things. So let's try another one involving the sum and difference formula. Alright, so let's prove that the sine of x minus y, oops, I wrote proof twice, sorry. Prove that the sine of x minus y plus the sine of x plus y can be simplified to 2 sine of x times cosine of y. Okay, So this time we're actually going to be writing two different expressions using the sine sum formula, and we're going to show that they equal 2 sine x cosine y. So again, once again, getting our trig property sheet out. When we do this the first time, we're going to make this our u and this our v. Okay, so I'm going to just kind of color code this. So this first expression, I am going to write sine of x times cosine of y. And since this is subtraction, the formulas and sine is the same sign. So minus cosine of x times sine of y. Okay, so that's that first expression. Plus, now I'm putting this together. So I'm going to do this in a different color, and this is now my u and my v. So once again, it's a sine formula. So sine of x times cosine of y, and then because it's addition, the sign would be plus cosine of x times sine of y. So even though there's a lot written in here, hopefully you can see this pink expression is the first sine sum, this purple expression is the second sine sum. So now I have the left side completely written out using the sum and difference formula. And what I'm trying to show is this. So keep in mind, these are terms. This is a whole term. And so if one is positive and one is negative, you can cancel them out. Hopefully you see the second term is minus cosine x sine y, and the last term is plus cosine x sine y. And so we can cancel those things out. And that brings us to then, I have two of these terms. So this simplifies to be 2 sine of x times cosine of y, which is the end of our proof. Okay. So just to show one more to make sure we have the hang of it. Okay. Let's do one more that is similar to a cofunctions identity. So the last one we'll do today is, let's prove, using a sine or difference formula, that the sine of theta minus pi halves is equal to negative cosine of theta. And I'm just using different variables because we know that we might see some different variables in our homework. So, what formula should I use for this one? I should use a sine sum or difference. So we pull our trig property sheet out again. So the bottom one. And just like before, just to help me out, because these are u's and v's, my u is going to be theta in the formula, and my v is going to be pi halves in the formula. So, I start by writing sine of u, which is theta, times cosine of v, which is pi halves. Since it is subtraction, I am going to write minus cosine of u, which is cosine of theta, times sine of v. Okay. Similar to the first example we did, we now have things that are exact values on the unit circle. And so I am going to swap those out for their values. So I have cosine of pi halves, which I hopefully know, and I have sine of pi halves. This is similar to the first example we did because that also involves pi halves. So now I'm going to take those highlighted expressions and I am going to plug the values for cosine and sine in. The cosine at pi halves is 0, so this would simplify to be sine of theta times 0. Minus the sine of pi halves is 1, so cosine of theta times 1. So sine of theta times 0 would cancel, and I'd be left with negative cosine of theta, which is what I was trying to prove.